Welcome back to the channel for practice problems for actuarial exams. We will work on the problem for exam MLC today. Here's some information about me and resources I offer to study for actuarial exams. So for example, this is where you can find my manual for exam MLC, smartURL.it /BTDT-MLC. BTDT stands for been there, done that. That's where you need to be when you take the exam and you look at every problem on the exam. You should be able to say, been there, done that. You should be able to immediately know what to do with this problem. And you get there by studying a lot, studying difficult problems, studying all the topics that are on the exam, and doing really challenging problems and doing a lot of them, and taking practice examinations under real exam conditions, so having the same time limits and so on. So this is a problem from old exam M, and it is in the set of sample problems that Society of Actuaries posted, number 207. You are given the survival function s sub x of x equal to 1 minus 0.01x, the whole quantity squared, for x between 0 and 100. Calculate the 50-year temporary complete expectation of life of a 30-year-old. So the word complete refers to a continuous probability distribution of future lifetime, and in this notation here it's indicated by that circle above the E, and E is the expectation of life. For a 30-year-old, that's the first subscript, colon angle 50, so this is joint life status for two lives or statuses, whatever you call it. The first one is somebody who is 30 years old, and the second one, angle 50, that's something that you actually know the meaning of from exam FM. That means something that lives exactly 50 years and then ends. So that the whole story here is really we counting how long a person will live during the next 50 years on average if that person is 30 years old. And of course, one very important thing you need to remember is that this is an expectation, mathematical expectation, expected value of a random variable, and the most convenient way to find expected value, especially on exam MLC, is the Darth Vader rule, that you should take the integral of the survival function of this random variable. Because of course this is future lifetime of the person during the next 50 years, but still future lifetime, so it's clearly a non-negative random variable. Random variable is non-negative with probability 1, and it has expected value because it's bounded by that 50 years in the future. So you may think for a moment that this is some kind of modification of de Moivre law, and then desperately try to remember what kind of formula was I supposed to memorize, to which the answer is, well, you should memorize all the formulas you can get your mind on, because that's the rational strategy for exam MLC, which used to be exam M at some point, and clearly at that time it was called the mother of all exams. But this is not modified de Moivre law. We just need to work the solution from the first principles. The first principle, the most important one about expected values, is the Darth Vader rule. And in this case, it's just the integral from 0 to 50 of TP30 dt. So probability of survival for a 30-year-old for every time in between now and 50 years into the future. And of course, TP30 is the same as the survival function of x, the future lifetime of a newborn, at age 30 plus t, divided by sx30. And we are given the form of that survival function. So we just plug that in. And it's 0.01, 1 minus 0.01 times the age, the whole thing squared. So we plug in those numbers, and of course 0.01 squared is 0.0001. 0.3 squared is 0.09, so 1 minus 0.09 is 0.91. So we have 1 over 0.91 in front, that's a number, and inside we need to calculate this integral. We just multiply things out, and it's a polynomial, and we take the integral from 0 to 50 of everything that appears there, and just do a straightforward calculation, and it ends up being 50 minus 750 over 91 minus 1250 over 273, so it's approximately 37.18. That's answer D. Please remember that this is copyrighted material, and problems from past Society of Actuaries examinations belong to the Society of Actuaries, while what I'm showing you is my solution, but I'm using these problems with permission. Good luck in your studies, and good luck on the test.